Hey everybody, this week is all about the metric system, and metric means measuring, so it's the system of measuring for most countries. So we'll cover what the units are and what the things are that you're measuring with the metric system. We'll cover what those prefixes are, like kilo or milli or micro or centi, and then we'll cover how to do conversions between different metric system units or units that are not in the metric system to change them into metric units. All right, so this set of notes will be on the metric system. We're going to start off with what the metric base units are, as well as some other derived units. Then we'll talk about what all those prefixes are that you hear, maybe like kilo, or milli, or micro, or centi. And then we'll talk about how to convert one unit to another. So the metric base units, these are what everything else is based on, and they're the units that different quantities or different properties are measured in. One of the properties that we might measure would be time, and the metric base unit for time would be seconds. There's a very technical definition of what a second is. It's based on the number of times a cesium atom vibrates, and there's a specific number of times that a cesium atom needs to vibrate, and that is the definition of a second. But for you to know, a second is pretty much like one heartbeat when you're at rest. Another base unit would be for measuring length. And the base unit to measure length is the meter. And just to estimate, a meter is approximately 3 feet. Another metric base unit would be temperature. And the metric system unit for temperature is something that's kind of like a degree Celsius, but it's a degree Kelvin. That's a capital K. Later on, it'll be important to note that because there are some things that use a lowercase k. But 1 degree Kelvin, like increasing temperature by 1 degree Kelvin, is the same as increasing it by 1 degree Celsius, except that there are no negative Kelvin temperatures. Absolute zero is 0 degrees Kelvin, which, because temperature is really a measure of how much the molecules are moving, absolute zero, or 0 degrees Kelvin, is when no particles are moving. And so when we say 0 degrees Celsius, the temperature at which water freezes, that is 273.15 Kelvin. And so while below this temperature, 0 degrees Celsius, we can have negative 10 Celsius, that would be 263.15 Kelvin. And so 1 degree change in Celsius equals 1 degree change in Kelvin, but this is 0 degrees Celsius. The temperature at which water freezes is 273.15 Kelvin. And again, no negative Kelvin temperatures are allowed. Another thing that we would measure throughout experiments would be the mass of something. And you might think that gram would be the base unit for mass, but it's actually, for some reason, kilogram. Even though it has a prefix, kilo, it's still considered a base unit. 1 kilogram is approximately 2.2 pounds. We'll talk about what kilo means in detail later, but a kilogram, 2.2 pounds, is 1,000 grams. And so if you're estimating what 1 gram is approximately the mass of 1 penny. Another metric base unit that we'll use would be the number of particles, or the number of things, a counting number. And to measure the number of particles, because particles are so small, is a unit called mole. And 1 mole of something is this many of those particles. And so 1 mole of iron atoms would be this many iron atoms. To write it out not in scientific notation would take more time, and I'll show you. So 1 mole would be this many particles. If somebody says 1 mole of iron atoms, it's this many iron atoms. If someone asks for 1 mole of gold, they're asking for this many gold atoms. Sorry, I forgot 1 0. Now, you may be looking at this list and thinking, well, we definitely measure other things in chemistry. We've measured number of liters or milliliters before. Those are not called base units, they're called derived units, because volume, like liters, is really the length, but in one direction, times its width, times its height. And so that is derived from this 1 unit of length. And so liter is a derived unit because it's equal to the volume that a cube would take up, that is 10 centimeters by 10 centimeters by 10 centimeters, so length, width, and height. Or it's 1/1000th of a cube, that is 1 meter times 1 meter times 1 meter, its length, width, and height. Another derived unit is called the Pascal, and it measures pressure, usually air pressure. And just as a reference, normal air pressure is 101.3 kilopascals, and that's approximately 15 psi if you're more familiar with pumping up your tires. Hertz is usually a measure of frequency, either of a sound wave or some other type of wave. And it means 1 cycle per second, or how many? Yeah, 1 cycle per second. Another one we will possibly use later would be joules in terms of energy. And usually you talk about energy in terms of calories, but the SI unit would be a derived unit, and it's called the joule. In terms of something more familiar, 1 calorie in terms of energy is 4.18 joules. Next, we're going to move on to the prefixes, and those are things that come Pre means before, and so they come before any of these unit names, and they always mean the same thing. A prefix always means the same thing no matter what unit it comes after. And they act as multipliers for that unit that comes after them. You should have received a version of this handout, and if you haven't, you'll soon get one. But it tells what the different metric prefixes are. SI means nearly the same thing as metric system. It's the Système International, it's French. But these are the prefixes. Some of these will be more familiar than others. It tells you what they mean in scientific notation, and it tells their abbreviation. One thing you can see here, it says MU, but really you should be using the Greek letter mu, which looks like a U with a tail in front. What I'm going to do is in the notes, I'm going to write the few that you're going to encounter in this class that you really should know. Like for instance, you will never work with an hexagram, or you're never going to work with femtoseconds in our class. So I'm not really going to focus on those. But the ones really to be aware of that you'll hear regularly: kilo, centi, milli, and micro. So the first one, kilo, is a prefix that means it's 1,000 times whatever comes after it. And so a kilogram is 1,000 grams. On the handout, it's written as 10 to the third, because 1,000 is 10 to the third power. That's the only prefix, the only common prefix that represents something that is bigger. The other three that I'm going to expect that you know would be things that mean that they are smaller than whatever is coming after them. Centi is a prefix that means that it's 1/100th of whatever you're speaking about, or 0.01 times that. That would be 10 to the negative second power. And so for instance, 1 centimeter is 1/100th of a meter. 1 centigram is 1/100th of a gram. Milli, like milliliter or millimeter, is a prefix that means 1/1000th, or 0.001 times whatever is coming after it. And so a milliliter is 1,000th of a liter. A millimeter is 1/1000th of a meter. And a millisecond would be, you guessed it, 1/1000th of a second. This is the one that I had talked about earlier, micro. Micro is a prefix that means 1/1,000,000th, or 0.000001 times whatever comes after it, and its meaning in scientific notation is 10 to the negative sixth of whatever comes after it. And so a microsecond is 1/1,000,000th of a second. A microgram is 1/1,000,000th of a gram. The symbols for these, now I said with temperature, that Kelvin, it was important to have that as capital K, because lowercase k is already taken. It's kilo. Lowercase k, centi, lowercase c, milli, lowercase m, and micro is that Greek letter mu. Next, we're going to look at conversions. If you have a quantity that is reported out in one unit, how could you change it to a different unit? So what you're doing when you're converting one unit to another is you're not really talking about a different amount of something. You're just changing how you're reporting or how you're describing that amount. So if I told one of my athletes that today they needed to go run 1,000 meters, and I told a different athlete that they needed to go run 1 kilometer, that would be fair because they are equal to each other. So conversion is changing the units and how you describe that quantity, but not really how big that quantity is. And there are a couple of concepts that make conversions work. So for instance, if I had a distance of 1.5 kilometers and I wanted to know how many meters it would be, I would do a conversion. And conversions work under the knowledge that multiplying a number by 1 does not change what it is. So 5 times 1 is 5, 10 times 1 is 10. Multiplying anything by 1 does not change what it is. The second key thing that conversions work off of would be that if in a fraction the numerator and denominator are equal to each other, that fraction is equal to 1. And the last piece of this that really makes conversions work is that units work just like variables in that they cancel out and combine. And so the general strategy for conversion is to take something that you're trying to convert and multiply it by a fraction where there are different units on the top and bottom of the fraction, but that the numbers that go in for those units are equal to each other. It's best explained through this example. And so we have 1.15 kilometers and we want to know how many meters it is. You always start a conversion by writing down the number that you're trying to convert with its units. And then you would put a time sign and a line. So this is going to be a fraction, which is called a conversion factor. And the fraction is going to have the units we're trying to get rid of and cancel out on the bottom because this is multiplication. And the units that we want to get to on top. So we're trying to get rid of kilometers and we're trying to end with meters. And now that we have our units in, we know that this would cancel and these would be the units we're left with. So that is how we're using this. Now, we want to make this fraction equal to 1 so that we aren't actually changing what our quantity is or what it means. So we need to make our numerator and denominator in this fraction equal to each other. And so we need to know, how many meters are in a kilometer or how many kilometers are in a meter. The strategy I always tell people is pick which of these is larger, a kilometer or a meter. The larger thing is a kilometer, and so we'd put 1 there, and then you would put how many meters are in a kilometer. Kilo means 1,000. And so we can see that if we did 1.15 kilometers times 1,000 divided by 1, that kilometers will cancel out. And as units, we would only have meters left. And we would have many. When you do conversions, it's important to keep your number of sig figs the same, your amount of precision the same. And so this had 3 sig figs, and so our answer after we convert also should have only 3 sig figs. We'll do some more examples. So we're going to run a couple of examples, and these are going to be from your assignment that's due on your remote days this week. These will be from your remote assignments that are do this week. It's broken up into two parts, one-step conversion and two-step or multi-step conversions. And the one-step conversions are all ones that involve a base unit with no metric prefix. And by one step, I mean that it would use one conversion factor, one conversion fraction. And we'll look at two examples there. How many milliliters are in 23 liters? That's one way to ask a conversion problem. Now, it doesn't say explicitly convert 23 liters to milliliters, but it's important that you understand the wording, that if it says how many blank are in blank, that is a conversion problem. And so again, the same steps. You start off by writing the number that is to be converted with its units. And then a time sign and a line for the conversion factor. The units you're trying to get rid of in this case would go on the bottom so that they will cancel out, liters. And the units that you want to end with would go on the top, milliliters. It's also going to be easiest if you put a 1 with the thing that's larger. So what is larger, a liter or a milliliter? That's right, a liter is larger. And milli anything means that there are 1,000 of them in that thing. And so to make the numerator and denominator equal, and therefore this entire fraction equal to 1, there are 1,000 milliliters in 1 liter. The way that you could put this into a calculator if you needed to would be 23 times 1,000 divided by 1. And you would get that there are 23,000 milliliters in 23 liters. A different example where you're changing a unit that has prefixes into the base unit would be to convert 5.98 times 10 to the 15th picograms into grams. So you're going to start off with the number that you are changing, which is 5.98 times 10 to the 15th with its units, picograms. Same thing, a time sign and a line. The units we are trying to get rid of would go on the bottom, picograms, and the units we're trying to end with would go on the top. Now we need to figure out which of these things is larger. Pico is a prefix that means a very small amount of a gram. It means 10 to the negative 12th of a gram. And so the thing that's larger, if you could have a gram of gold or a picogram of gold, I hope you realize that you would rather have a gram of gold. That is the larger thing. And the number of picograms that are in 1 gram, it comes from the reference sheet, and it's 10 to the 12th picograms. And this is where people get confused about how to use the reference sheet. Because the reference sheet says that for pico, it's 10 to the negative 12th. But what that means is that 1 picogram is 10 to the negative 12th grams. We could have technically put a 1 on the bottom and a 10 to the negative 12th on the top. I personally think that it's easier to stick with large exponents instead of the negative exponents. Large numbers and positive exponents over small numbers and negative exponents. And so for these, when you would use them, for milli, you wouldn't put 10 to the negative 3rd milligrams for 1 gram. You would say it's 10 to the 3rd milligrams for 1 gram. It's 10 to the negative 3rd grams in 1 milligram. So understand what this table is telling you. So here, these are both in scientific notation, and it's important to remember your exponent rules, that when you have two numbers that are the same base, but different exponents, and when you're dividing, you're subtracting. And so it's 10 to the 15th divided by 10 to the 12th would give us 10 to the 3rd. And so our answer would be 5.98 times 10 to the 3rd grams. Next, we'll look at two-step conversions. In a two-step conversion, I like to have the first step be to first change it to the base unit. And so some examples of those that you're expected to do. One of them, it says how many microseconds are in 2.8 milliseconds. And so the thing that you are converting is 2.8 milliseconds, a time sign, and a line. Now, in the one-step conversions, we were putting what we wanted to get rid of on the bottom, which is still the strategy we're going to use. But in the first step of a two-step conversion, we're changing to the base unit, which in this case would just be regular seconds. Now what's longer, 1 second or 1 millisecond? That's right, 1 second is longer. And milli means that there are 1,000 of these in one of the base units. So that's 1,000. We also could have put 10 to the third. So 2.8 milliseconds times 1 over 1,000. Milliseconds would cancel out, and we would be left only with seconds. But in the question it says how many microseconds, and so this is not a complete answer. So we would do one more time sign and a line. This time we have seconds in the numerator. To cancel it, to get rid of it, it would go in the denominator, seconds. And we would put our final unit that we want to end with on the top, which is microseconds. There are a couple of ways to write this. First, which one is a longer amount of time? Is 1 second larger or 1 microsecond? Hopefully you realize it's 1 second. And then the number of microseconds that are equal to 1 second is 1 million. So you could write that as 1 with 6 zeros. Or you could have written both of these in scientific notation, 10 to the third and 10 to the sixth. If you understand scientific notation and exponent rules, this can go much quicker, because you would see that you have 10 to the third in the denominator and 10 to the sixth in the numerator, and so that 3 of those would cancel out on the exponent, but also you see here with the zeros that 3 zeros would cancel out. And so really, if you wanted to do this on a calculator, you could. You could put this into your calculator in a number of ways. It could be 2.8 times 1 times 1 million divided by 1,000 divided by 1. Or you could say 2.8 times 1 divided by 1,000 times 1 million divided by 1. Or you could do it in your head if you are understanding the exponents and scientific notation. And you would get 2.8 times 10 to the third microseconds, or possibly your calculator would tell you 2,800 microseconds. So I hope that was all clear enough for you all. We'll do lots and lots of practice, even if you don't think what you have done so far is practice enough. Conversions is not something that you can just do one and done, and we're done with it for the year. Conversions are something that are going to come up all year. So please, if you're struggling with this, don't think that we're going to be done with it after this week. Make sure that you get this skill down, because it is not going away. It's a really big part of chemistry and physics and really all upper level sciences. So if it wasn't enough, feel free to answer questions and I will get those answered. Thanks for watching.